All right. Well, ladies and gentlemen, here it is. The final presentation in the architecture track at Spring 1, 2021. And when it comes time to land the plane, you turn to a true professional. And that's why I'm so delighted that I get to hand things off to Billy, who's going to teach us all about Java and how to get good at automating testing inside our Java worlds. So, Billy, bring it on home for me, buddy.
Fixed audio. So thank you for that introduction, Nate. Happy to bring it home. And with that said, I only got 25 minutes here. So let's just go ahead and get it going. How to be a Java automated testing superstar. My name is Billy Korando. I'm a Java developer advocate at Oracle. And you can find me on Twitter at Billy Korando. So some important notes. I'm a demanding speaker. I want you to ask some questions, though. We're going to wait until the Q&A section after this presentation, but I'll be there and happy to talk to you when that happens. Again, reach out to me at Billy Korando. Feel free to DM me or just tweet at me, and I'll be happy to answer any questions. Or if you want to also have like a longer conversation, shoot me an email at billy.korando at IBM or at Oracle. Sorry, went back to about 8 or 9 months ago there. The key link to know is this presentation is available here. So also some links, there's be some code and other stuff. Just really, this is the only link you need. And from that, you can get to everything else. If you also do leave this presentation with an intense desire to know more, a lot of what I talk about during this presentation, I have also covered in various blog articles on my website. So not just really self-promote, but just to kind of, if you want to get some more information, because again, 25 minutes going to be flying through some stuff here, but you want to get some really depth on something that sounds really interesting. Be sure to check it out there. And I probably already covered it in a more extensive blog article. All right. So why write automated tests? They require a substantial time and effort to write tests. Really, if you're writing a quality automated test, you might be spending as much time writing automated tests as you are writing your quote unquote production code. Also, over time, it's going to take a lot of time to actually maintain these tests. Even the best written tests and these best reliable tests, which I'll be kind of covering a little bit later, you got to maintain them. Your code changed. That means your test is going to have to change. If your code's changing, your tests aren't changing, well, that's probably going to be a problem. So if your code is perfect like mine is, like I've never written a bug in my life, why should we waste why should you take all this time and effort writing tests? Well, I'm sure this spot been covered a whole bunch during at some point during Spring 1, since many of the people on the Spring framework team heavily depend upon CI/CD processes. But really, any sort of CI/CD process, continuous integration, continuous delivery, is going to depend upon a foundation of automated tests. No organization is going to ship code of any merit or any real use to production without actually testing that code. And of course, within a CI/CD process, that process has to be automated. Now, traditionally, for many organizations and many organizations I've been in kind of before making the shift over to automated testing, developers would commit code, and hopefully you would have some sort of a CI process like Jenkins that would actually build the code and maybe deploy it out to your QA region. But then from there, it may be depending upon some sort of a manual testing process to really evaluate the code to make sure it is in good working order, meeting business requirements and whatever sort of quality needs that your organization has. And really that process is going to take hours, if not days to complete, from when the code's available in that development region to when you're feeling safe to go to production. Now, maybe in some sort of a break fix issue, you can kind of really speed up that process. But the real big thing with manual testing, or at least one of the big things, is that there is a substantial human labor cost associated with it. It could easily be dozens to hundreds of hours, depending on the size and complexity of the application you're testing per release cycle. So, and where this can start to become a real problem is particularly within your dependencies. So we as developers, we spend all of our time writing our code and working on it. And we may get like an idea that the code that we're working on, that our organization has written, is the majority of the code that you've actually been pushing out to production. But the reality is it's actually only a very small fraction of it. Really, the code that your code runs on, your Spring framework, and all the libraries, dependency that Spring depends upon, like say Jackson for kind of transforming to JSON and transforming from JSON. And so many of these other libraries is what you're running on. Or of course, Java itself is something that your code is running on. And within there's going to be a lot of security, performance, and feature enhancements that you're going to be missing out on if you're falling behind on your dependencies. And particularly, by far, the most important of those really is security. We all kind of remember the infamous Equifax hack from 2 or 3 or 4 years ago, or maybe it's been a bit longer. Time no longer has meaning. But the way that hack occurred was through an exploit. I believe it was an Apache Struts. But the truth is that exploit had already been fixed by the time Equifax got hit with that hack. It's just that dependencies were probably out of date, probably well out of date. And so why that often happens within organizations is because of the high effort with regression testing code. So I have a lot of trust in Spring and their testing process, but of course, they're not perfect. No organization's perfect. So, we may be on Spring Boot 2.5.4. I believe that's the second most recent version. And now we want to move up to 2.5. But you just don't quite know, if you don't have good automated testing, what's going to happen if you make that switch. And then because you don't know what could happen, that's going to disincentivize wanting to update that. Or if it's going to be a huge manual testing effort, it may be like, we're just going to wait a couple of these patch releases. Like we only maybe go from major or minor release to minor release, or major release to major release. And so you slowly start to get out of date. And there's also all those changes start to pile up to where going from, I think it's 2.5.3 is the second most recent to the most recent 2.5.4, where that's probably going to be a very small change. But if you start to get several versions out of sync, well, it could become much more substantial, much more chance for breaks to happen. And so again, it starts to build up on itself. And eventually organizations are far, far behind whatever the most current version is. And so now they're having unsecure code, which is by far really the biggest issue out in production, but they're also not going to be able to get the best performance, and then also missing out on features as well. Our developers will be missing out on some of the newest features to be able to take advantage of. So by moving to an automated process, well, developers can again commit their code as they were before. And then that can kick off a fully automated process where you're going to build and test your code, and then automated process is going to kick off, and eventually it's going to end with it going to production or going to a near production region with maybe, some sort of manual step just to actually say, okay, go to production now, where there's not really any sort of validation happening. Maybe you just don't want to have a deployment to production happening right in the middle of the day. But the important part is that these automated process, well, it's going to be measured much more in minutes to maybe an hour or so, depending if you have a very complicated automated test suite. But also there's going to be very low labor associated with it. So if you do just want to do that bump up to a new patch release or some dependency, it's not going to be that concern of like, oh, doing this is going to have to kick off a huge investment in testing. It's like, okay, update it, and you can let the automated testing process go to make sure that none of your code was affected, at least negatively, by the update to the dependencies. There's also some other additional benefits. So again, of course, the speed and labor cost savings are huge benefits, but actually 2 other really, really, really important benefits to automated testing over manual testing as well. The first one is that it's actually truly auditable. So when you write out your automated test, well, you can review that test code. You can review reports to make sure that, oh, okay, all of our tests actually executed, or they all executed, but a couple of them failed. And you can see which one failed in, clear detail. And of course, you can also look at any sort of logging that either your test or the code generates and, kind of review what was actually happening. And that's something you can't really do with a human. A human could truly think they maybe went through and did their test script, but maybe they did it in the wrong environment. Maybe they skipped a step, did a step in out of order, or maybe they did something a little bit different. Maybe they accidentally fat finger the space bar when going through some forms, and they added a space to a field, and that caused some sort of error or something. And it's just really hard to maybe track what happened because, well, they just maybe weren't aware that they did something wrong. So having true auditability from automated testing is extremely key. Another key thing is the repeatability. Again, humans, we're not good about doing everything in precisely the same way every single time. We can get pretty close, 90, 95%. But, of course, within that 10 or 5%, well, that can really start to add up to a lot of different variants. So if something fails in a test, well, you can just rerun that test suite to see if did that fail again? Okay. If it did, then there's definitely something in your code. If it didn't, that's also something worth investigating because you really want your test to succeed every time. And if it's failing, that means it's something very meaningful. But at least you can do that because that your tests aren't changing, whereas you're not going to be certain every time a person runs through a test script, they're doing everything exactly the same. And of course, also you can easily run your test suite against maybe different versions of your code if needed to see if wait, did this problem happen in a previous version? If it didn't, okay, well then, that's definitely something changed in your code. Or maybe if it also failed in a previous version, well, something's changing in your environment. And of course, you need to investigate what's going on there. But those are some key benefits that you really can't get with human-based testing, or at least you can't really get to the same fidelity that you can with automated testing. And in many ways, I think are some of the biggest advantages is that automated testing offers you. All right, so obviously you're to some extent already kind of bought in on the idea. Sorry, got out of order here. So one other thing is that often when the topic of automated testing comes up, the idea of sort of a very metrics-driven idea on how to do automated testing comes up. Sometimes the thing that comes up is how much unit tests or how much test coverage you used to have. Should it be 70% or 80% or some other sort of specific metrics like that? And really, that's just the wrong way to be looking at it. What you need to do is whatever gives you confidence to deploy to production without manual intervention or really any sort of manual testing, that is what you're going to be wanting to aim for. It's a bit of a cop-out, but really, it's always going to kind of vary across organizations and really within an organization, depending upon the application. Whatever sort of applications are just absolutely critical to the functioning of your organization, well, you're going to want a lot of really good automated test coverage around those. If you have some sort of weekly batch process that, just kind of checking some stuff and it's doing something meaningful, but it's maybe not something critical. If it fails once or you can go through and there's ways to back it up, well, then you probably don't need quite as high of a automated test coverage on that batch process as you would of this, extremely critical software that's just central to your business. So that's also maybe one reason you don't necessarily want to do arbitrary things like maybe code coverage. And also there's a lot of ways that can lie, something we'll briefly touch on here a little bit later in this presentation when we get to just a little bit of some live coding. Now that said, I kind of was really talking about automated testing entire part before this, but there is still a role for manual testing, even in an organization that has very mature automated testing practices. And but in that case, it's really going to be exploratory. It's not going to be a part of the actual deployment process. It's just going to be kind of something that's going to be always kind of going on in parallel or a background, or a case where you might be, depending on the type of applications your organization is building and running, you may be dog feeding as a developer where you would, work with your own applications as part of your development process or your otherwise working process to make sure that it's actually fulfilling the goals of what your organization is setting out. But again, that's more about exploratory. It's not going to be, we need to do some manual testing to actually then before we push to production. All right. This is what I was about to get to before. So we kind of cover why to be doing automated testing. So, and maybe organizations are already doing that. And I kind of cover that stuff just to help encourage you and maybe get those arguments for why you should start doing automated testing in your organization. But how do you become a Java automated testing superstar? Well, there's a few ways or a few things you should do. One, and I remember the great Angie Jones, who kind of gave like a part of the opening keynote at this point in Spring 1. You really need to treat your test code just like production code. You can't just be like, oh, okay, this test code, who cares? You know, we don't have to worry about making sure it's extendable or you can be easily built and expanded upon. We don't really need to care about whether it's readable. It's just test code. You should treat it with all the same thought and care of your quote unquote production code, your test code. And of course, it's also really important to make it human readable. Now, to that end, there's a bunch of libraries out there that can kind of help with that. I'm not going to have nearly enough time to do it justice. I know Sam Brandon, who's like the lead of the JUnit 5 project, gave a presentation earlier, and hopefully if all these are recorded, definitely go check that out. But JUnit 5, actually upgrading into using JUnit 5 versus older versions of JUnit, I would highly recommend. There's a lot of key changes within it that improve the testing experience. For example, like a lot of the assertions behavior has been improved. Instead of having to do like catching your exception and the annotation, like with the expected exception, you can do assert throws, return that exception, and that way you can more easily, maybe you're checking the message of that exception. You can do that more easily this way than having to do like a try catch. If you've ever had the issue where you've had multiple assertions within the same test, and then those assertions start failing, you have to like run a test a bunch of times, you can now actually wrap that all up and assert all, and you can, of course, get back all the assertion errors at the same time. Parameterized tests have seen quite a few improvements as well. Whereas an entire class was devoted to parameterized tests in JUnit 5, parameterized test is actually now just an annotation you throw on the individual test case or method level. And then you can even have other test case within that same test class. That's really nice. I ran into one issue one time where I had about a dozen different scenarios to go through, and I could cover most of the parameterized tests, but then I had to toss a couple of these other scenarios in a separate test class, which was really annoying. So that's a really nice change parameterized test. The one last thing I want to touch on specifically within JUnit 5 is the ability to write dynamic tests. And this can be really great for covering cross-cutting concerns. Now, in this test code, I have like a really simple REST API. And I just imagine with this RESTful API, I have two types of clients. One type sends me XML. Another one sends me JSON. So my post endpoints or put endpoints, they need to accept both types of media formats. So in that case, writing this test factory can actually scan my code to see for any sort of post endpoints I have, and then automatically generate tests to make sure that each of those endpoints are accepting XML and JSON. And this is where also code coverage can fail you, because you could write a test to make sure you're accepting JSON, but then not one for XML, and that would never really show up in your code coverage. And of course, that test just doesn't exist, so it wouldn't show up in maybe a failing test or something like that as well. But we can quickly see that here, how this can expand and grow with my tests or with my application. So running this one time, hopefully it'll complete here quickly enough. So we have 4 tests that are completed. We can see here 4 of them. Now, if I go into my code real quick and I simply comment out this post mapping and then rerun this test, instead of 4 tests, I should only get back 2 test runs. And yeah, so I got 2 test runs because now I only have 1 post mapping in this example. So you can see how without having to constantly take the time to update these tests, it evolves with my code, and that can save a lot of time for your developers and help encourage writing automated tests. Barely touched on in JUnit 5, just in 2 minutes, not enough to do justice, but you can also do parallel test execution, order test, repeated test. The extension framework's completely rewritten to where it's much more extensible. Ways to do selective disabling, default test with interfaces, and so much more. I'm sure Sam covered all this in his presentation that was just like a little bit earlier today. So definitely probably want to check that out. Also, though, when writing these tests, a key point is having fluent assertions. So assert are the default ones that come in JUnit 5, they work well enough, but with assert equals, for the longest time, I think I actually had it backwards in how I was writing tests, where my expected value or my actual value, I would put it on the left side, and the right side, I would have the expected value, but the correct side is the expected value supposed to be on the left and the actual on the right. The point is, it's confusing, a bit, and like there's no right way of doing that. With assert J, you can simply have like a much more fluid, human readable, and language way of writing it, which is like assert that whatever your expected value is, or whatever your actual value is, and then is equal to your expected value. And that's how all the assertions within assert J are built up. Moving on quickly. So I talked about repeatability, which really kind of gets to reliability. And one of the most difficult areas of doing reliability in AMA testing is with integration tests, but luckily some modern tools have really greatly helped improve that. One of them is test containers. And here's a really simple example of a test container where you can set up you can call to your organization's test container library and pull down an image that maybe matches what your Postgres database that your application is running on actually in production. So you can pull that down and then actually test your code against that, instead of trying to test against some sort of like integration or QA instance where that code, you don't have to worry about that, like the service being down. You don't have to worry about test data going missing or going stale. And also you don't have to worry about maintaining like a local instance on your machine of a Postgres database, which can be very time consuming. You can quickly get it out of sync. And then you also have no idea between the individual developed machines if everyone's keeping their local Postgres or whatever service instance up to date correctly. From there, also, one area that's also extremely difficult is performance testing. And I've only just got it started messing with or playing with it, and it only just got released as an alpha release. But JFR-Unit, which stands for JDK Flight Recorder, what it can do is JDK Flight Recorder. It works just kind of like the flight recorder within an airplane, where it's checking, fuel usage, altitude, speed, like all the different things and about the performance of an airplane as it's flying. And then that information can be downloaded and, processed to see how that aircraft performed. JDK Flight Recorder works the same way, where there's a bunch of events being sent out, and you can use that to check to see, like in this case, memory allocation events. JFR-Unit allows you to actually do that within a test case, and it builds upon JUnit 5. And that's where you can actually get some really reliable ways of doing performance that would actually be then, because you're testing the performance of the JVM, which would be consistent as long as you're using the same version of the JDK across your systems. It wouldn't really matter the actual system you're running these tests on. It should be consistent across systems and environments. So that way, if all of a sudden within your test, like, you see your allocation events suddenly suit up a whole lot, you can know that, hey, maybe there's something changed in my code, and it's not maybe some other thing that's going on with the performance test, which can maybe sometimes be very difficult to track down when you're testing an entire system in a whole environment. The last one we're going to talk on is contract-driven development, specifically using Spring Cloud. What Spring Cloud allows you to do is to define these contracts, which then can test your application. In this case, a RESTful API, like I'm going to call API v1 produce with a get. And if I call that API or of that URL, I'm going to expect to get back a 200 response and this kind of response back, and it's going to be JSON and starts at UTF-8. You can fully define this. It doesn't just have to be successful requests. You can also define error requests as well. But then we can also use this is to use these contracts to make sure that the service is testing your RESTful API is matching those contracts. But what Spring Cloud also allows you to do is to take those contracts and set up a mock of that service. So that way, the clients or the front end UI that you're using, you can take that and actually then test it against that mock service. And because that mock service is, again, is based upon those contracts, which are then validating the actual real service, you can have confidence that that is all actually going to be reflecting reality once you get to production. All these code examples can be found on my GitHub and so just definitely check those out at some point. And with that, thank you very much. And I have about 2 seconds left. So.
Like a professional, on time, on budget. Well done, Billy. I found myself in violent agreement with everything you were saying, especially the part about having never written bugs. So, 100% agreement with you there. Thank you so much, my friend. Head on over to the QA widget here. Friends, here it is. It's the end of Spring 1, 2021. I want to thank you so much for hanging out with us. I really, really appreciate it. And while the last 18 months has taught me that any kind of predictions about the future is completely futile, I do hope that we'll be in person next year, but we'll see you hopefully in 2022 and we'll get to actually be in the same physical space. But thank you again for hanging out with us, and we will see you next year. Cheers, everybody.